Welcome, everybody, to today's live event. Are agents the secret to quantum R&D success? We have this Quantum Insider live event hosted by Haiqu. Leaders from across the quantum ecosystem will share their honest takes on what's working, what's hype, and what the field still needs to figure out. My name is Brian Lenahan. I'm the founder and chair of the Quantum Strategy Institute. And we have a wonderful session for you here today. And I'm going to let our other speakers introduce themselves. And I'll have Richard from Haiqu start by introducing himself.
Hi, everybody. Thanks for joining us today. I'm Richard. I'm the co-founder and the CEO of Haiqu, based in New York City, in Brooklyn. And I'm very excited to share our views today with you.
Thank you, Richard. I'll go with Richard Padbury next.
So we've got two Richards on the call today. So I'm Richard Padbury. I'm Director of Quantum Research at KPMG, and I'm dialing in from Raleigh, North Carolina, and really excited to be here. Thank you for having me.
Fantastic. Thank you so much. Falgun.
Thanks, Brian. Hello, everyone. I'm Falgun. So I'm part of Capgemini's Quantum Lab, where I'm the head scientist leading a lot of different industrial topics. I spend most of my time looking at materials discovery, molecular modeling, industrial R&D, and how do they all play different roles and how do they come together. And I'm really excited to be here. So thank you for having me, Brian, and the Insider team along with Haiqu.
Thank you. And finally, Alexander or Sasha.
Yes. Hello, everyone. I'm professor at the University of Sheffield, and I'm also the director of the Sheffield Quantum Center. So what I do is developing quantum algorithms for different applications, and we are very much interested in agentic research working with Haiqu.
Excellent. Thank you. So we are fortunate to have people from all over the globe, people from Saudi Arabia, from London, from Barcelona, Norway, Belgium. We're thrilled to have you here. If you haven't already logged in and gone into the chat, please let us know where you're from. And today's session will be very interactive. We'll be having lots of conversations with each individual expert. Certainly place your questions in the chat as we have people here to help answer those questions, make connections with others. If we have the opportunity and we have the time today, we'll do a poll or two. So I'm actually going to start with our host, Richard Gavan. Can you tell us just a little bit about the role of agentic AI in the whole R&D workflow? Can we start there, and then we'll talk about quantum a little later?
Yeah, sure. So we're building what we call an agentic OS, which is really a system for directing a team of agents to work on different R&D subprocesses. And the reason we do it is because there's two issues. One is that we feel like the time it takes a user to go from the ideation of an application to its execution on the hardware can be very long, especially for a novel idea. And it means in enterprise, POC cycles can be as long as 6 months. And that means the trial and error that you're able to do, let's say Advantage comes in 2 years. If you do one POC every 6 months and you can do two in parallel, then you do eight POCs within 2 years, which is probably far too few to empirically discover Advantage. So we need to speed up that results cadence. And what's slowing it down is there is a skill gap. So you might have excellent researchers that understand exactly what they want to build in principle, but then you need to optimize that application. You need to tailor it to the QPU. There's a lot of domain specific and application specific adjustments you need to make it run. Often entire quantum teams don't have all the right skill sets within them, no less an individual. So the agentic OS just gives anybody the means to ideate all the way to execution very quickly. And so that's the purpose.
Yeah, and so AI agents can be a very large spectrum of different roles within any given workflow. But is the basic advantage a 24/7 operating capability, or is it something more complex?
It's really just about closing the gap. So as a researcher, you need to come with an instinct about what it is you would like to do. You can have agents do certain things autonomously, like do a literature review or do the classical baselining or the plotting for you. And then there's processes that are more collaborative. For example, let's say you're doing quantum machine learning, the new design of a new ansatz. You want to learn from the agent and then contribute your own knowledge to design something new, and then use the agent to prototype and test that quickly on the device. So it's about closing all the smaller skill gaps and also letting the agents do some of the menial tasks autonomously, like classical baselining, that nobody wants to do. So it's many things.
So you're taking the best of each world through the workflow. That's fantastic. So, Alexander, quantum computing is described as a powerful future complement for specific problems. How does quantum, from a Sheffield Quantum Center perspective, fit into the R&D workflow?
So our idea is to work with companies that are end users of quantum technologies to actually understand the answer to that question. And it is very important that we do it now, not when the machines are built, not when you already have the software suites ready, and then you try to find where to apply this. We need to co-develop these solutions together with industrial partners. And that's where I see academics can help. So we understand the theoretical research, we know what can be done from the experimental perspective. We hope to translate this into the industrial domain. And there are many areas where we see potential. So if you want, I can later expand on solving differential equations.
Yeah, let me follow up on that. Specifically, if people don't know the work that you're doing in Sheffield, can you give us some examples?
Yes, sure. So as a theorist, I develop algorithms that can be quite general, but we also work on application-driven research. For instance, work that we have done with Pascal on solving differential equations. Pascal is a large company doing neutral atom quantum computing, and they came with the question, how can we solve nonlinear differential equations in different domains? And we develop a bespoke set of algorithms that can be either deployed in the near term just to try and see how these solutions work, or develop fault-tolerant protocol for future advantage. And it is important that we understand the limitations now and consider relevant use cases like simulating turbulence or aerodynamic flow.
That's great. And I want to come back to you a little later on some of those examples. Falcon Capgemini is a large organization, well known for its sort of consulting capabilities and, interaction with clients. But can you tell us a little bit about what you're doing in the Capgemini world?
Absolutely. As you rightly said, Capgemini is quite big, right? 420,000 people and growing because the new acquisitions every other month.
Mm-hmm.
What many do not know is Capgemini has a very large engineering and scientific capability. It's like 65,000 engineers and scientists part of Capgemini engineering R&D and in other parts of Capgemini. So we actually have a lot of experience and expertise looking at scientific problems and also providing scientific consulting. And we work with a lot of end users in multiple industries in physical and life sciences, be it pharmaceutical industries or be it construction and manufacturing, or people who design materials themselves or batteries. So Capgemini usually has a role to play there, be it software development or deployment at scale, or even doing R&D problems themselves. So we take on that role as well. And within all of that, so my role as the head scientist of Capgemini's Quantum Lab, I also have one more role of being the global materials lead as well. It's bringing together what problems are worth solving and where does quantum actually fit in. And can we be credible? Because at the end of the day, there are multiple layers or multiple phases, if you will. You have the technology part where you really want to be credible, you won't be understanding the problems. Then there's the application development part where how do you actually apply it? And where do all the different parts of the puzzle, including AI, traditional computing, and quantum computing in the future, and along with cloud infrastructure, how do they all come in? That sits in the application layer. And then, of course, you have the commercial element. So I primarily focus on the first two, working quite closely with the commercial side of things too, and bringing them all together. So that's my primary role.
Fantastic. Before I get to my follow-up question there was a question that asked, could you share a few case study examples of where the quantum flow implemented in Capgemini, even if it's simply a link to Capgemini and your information site? And
Wait,
so
can you repeat the question again?
Sure. If you look in the chat, there's a question from Sarvana asking for a few case studies of where the quantum flow was implemented in Capgemini. So just even if it's simply a link or a paper.
Absolutely. Yeah, I'm more than happy to share a few links in the chat.
Wonderful.
Because we publish quite regularly.
Fantastic. Thank you so much. Richard Padbury, KPMG, again, known for its consulting practice. What is the Quantum Research Group at KPMG?
Yeah, it's a great question. Thank you, Brian. So again, I'm in good company here with Falcon, because I think KPMG is mostly well known as being one of the big four. So we're a big tax advisory and audit firm. But I work as part of enterprise innovation. And so I work with a team of experts that are building capability on the latest technologies, whether that's quantum computing or AI or other technologies that are coming up just behind it. And so we're building that capability internally. We are actively researching use cases across sectors. So obviously finance is a big area for us, but we're also looking at healthcare, life science, material science and chemistry. As a chemist myself, is also a key area of focus for us. And also we're seeing a lot of activity in telco and space. So you think about all of the latest developments, putting satellites into orbit, lots of optimization problems there. So we're doing a lot of work. We work with startups. We're working with the hardware providers. Again, our goal is to come up to speed on those technologies, build a practice, and then be able to help our customers and partners adopt this amazing technology as well.
So this is fantastic. You can see, based on the conversation we've had so far, there's a very wide spectrum of people involved in quantum R&D and in research and development, from pure lab to conversations that you're already having with clients about pilots and POCs. How interested, how excited are those people that you work with about this technology, or is it really just dipping their toe in the water?
So I think you see a broad spectrum. So there are organizations that have been exploring quantum for many years, maybe since the first quantum computers were made available on the cloud. So you have a number of organizations that have already come up to speed. Maybe they're building pilots and POCs already. And then, of course, there are organizations that are still trying to establish what this new technology means for them. So it's a very broad spectrum. And I feel I'm in a privileged position, because it's actually really interesting being able to interact with different partners and clients at different stages of their journey. It keeps the conversations very, very interesting. But I do think this year just feels very different to previous years. It's very clear that the hardware is improving. There's new algorithms. The software is getting better. And so this year really feels, I won't say it's an inflection point yet, but it feels different. It's getting very exciting, very interesting. So now is a good time to get stuck in.
Well, we're certainly hoping that, today's live event is going to give people the idea that there are resources available, whether it's our speakers here or, connections that they're going to make. Again, this is, something that the Quantum Insider tries to achieve with each one of these live events. Richard, we want to make this a little bit more tangible for our audience. And so I know that you have a product offering. We just want to give people an example of what that might look like. Would you be kind enough to share that with us?
Sure. I think this is Richard G, right?
Richard G.
Would you like me to share it visually, Brian, or just talk about
Why
it?
don't you if you could just give us a brief preview of, Many people may not know Haiqu yet. And so, a little bit more about that.
Sure. So I will share my screen very quickly and give people the visual aid. So Haiku builds two things, and they're interconnected. We build a quantum runtime layer. So it's really an SDK that you can use to build and run applications at larger scale. And we're coming out with the second tier of the product, which is this agentic OS, which sounds like a buzzword, but does in fact refer to something real. And I've zoomed in here on an example, but what it really means is you can establish the R&D process as a graph in which each node in the graph is some R&D subprocess. So if my goal, for example, was to build an application where I'm trying to compare genomic sequences, which is one place where people think quantum computing might find advantage, I can use this agentic OS to formalize the problem, to do the literature review, to construct the vision, and ultimately to build the application circuits and then run them on the device. Some of those processes I can run autonomously. Some will be collaboratively, where I'm working in a chat-like manner with the interface to come up with a new solution and develop it. And the goal is not to replace the researcher. We don't think you can. So consider it a research assistant. Most of the things it's doing autonomously are the things that people don't want to do themselves, but you still need the superiority of human abstract reasoning to create something really new. But it does speed you up considerably. You can go from a executed prototype, from an idea to that in a couple days versus what would have taken weeks. So it's beneficial. And my last plug is that it's totally free for anybody in academia. Both the SDK and the agents are all free to access if you're within academia. So yeah, I would leave it there.
Okay, well, we've got comments like this looks like fun from Evie Hines on, one of our audience members, and I think she's absolutely right. Especially when budget can be an issue for a lot of academic organizations and R&D institutions, and your solution, amongst others, are escalating or elevating that to a whole new level. Have you had any sort of near-term cases that you've been working on? Genomics, you mentioned.
Yeah. So on the topic of costs as well, let's say the general goal of Haiku is to speed up the publishing or research cadence so that people get to advantage. Part of that is lowering the cost to test things on the device because it can be prohibitive. It can be tens of thousands to test like one variational job. And it ultimately means that you don't take things from idea to execution, which means your R&D cycles are truncated. And so the middleware itself, accessible via SDK, can dramatically lower the cost of running on a device for a certain quality of results. So you can get very good quality results at considerably less cost. I'll put a blog in the chat where we can show that in action. In terms of applications, you can build anything with this stuff, but people are very interested right now in these sort of sampling engine style applications, like SKQD or sort of feature mapping within QML. There you're using the quantum computer like a state generating machine, pulling some new quantum enhanced information from it and putting it either in downstream classical machine learning or in a downstream classical diagonalization. So there's these sampling based methods. You can build any type of quantum application on it. It's a question about whether it will run or not. And so the job of the middleware is to make it run. But this system will evolve to being fully fault tolerant capable very soon as well. So you'll be able to do fault tolerant applications, and eventually you'll be able to create self-evolving applications, where you've created an application, then as the hardware itself changes, your applications are renewed in scale by the agents.
Well, that's exciting. The tools are just getting so much better. Sasha, from your perspective, maybe free tools are good, but what are some of those cases for which you use such a tool?
In fact, Brian, we actually use the tools from Haiqu already as a beta tester. So it is fun. It is fun to play with agents, and the SDK is very helpful. So I would say yes, being an early adopter of this technology just makes a huge difference. And researchers by nature are curious. Like we are curious to try something. We want to know how things work. So if you got this agentic OS or generally new tool, you want to understand where would I use it in my workflow? How much can I cut down the cost of the research and development? And can I really outsource some bigger tasks to agents? I think everyone agrees that we can cut down on the boring stuff. We are still discovering whether some genuinely new breakthrough type research can be done by agents, but soon we will see what we get with those tools. So I am excited, and I think it's a great opportunity.
So that's great. And I want to stay with you just in terms of the human in the loop aspect that Richard Gavan mentioned. What are you hearing from your researchers? What are they thinking about this?
It's a very interesting question. It really depends on the level of seniority, or rather experience you have in the field. So what we see, and we had the hackathon last week with a group just to discuss it for the full day. What we see is if you got an experience before, it is much easier to stay in touch with an agent occasionally and just steer it direction that you want to go. As you go to less experienced researchers, you really need to learn. So in that case, you call agent as a companion in doing research, but you will need to stay in touch and co-develop together. So there are different modes, and we need to learn how to operate with agents.
Okay. Before I get to Falcon again, thank you so much for your questions in the chat. We will be recording this live event session and replay it later. And that would be through our Quantum Insider friend hosts. Falcon, when you think about the work that you're doing, what are some of the barriers that you see or challenges that people in our audience might run into?
I think a big challenge that we do see from time to time for people wanting to get into quantum computing is often they're not asking the right questions. We have seen this multiple times. People are interested in quantum because it's shiny, right? Oh, this is something really new. I want to try it, which is good. And there are a lot of initiatives. IBM has a cloud platform now for 10 years that people are able to experiment. Often the biggest challenge that I've found is identifying, is a tool that we're interested in using, is that the right tool to be using? And this is a key part for me to even design a solution for all the different areas that we look at. And what was the other part of your question, Brian?
I was just asking your team's experience with barriers to achieving quantum R&D success through agents.
Yeah. So the other part is also, at the end of the day, quantum is still a developing field, quantum computing. And in the future, we expect it to be used as Microsoft Office tools or coding like Python. 15 years ago, people had to take a whole course. They had to have a degree to be able to code in Python and data science. But now it's part of everyone's high school curriculum. But we're not quite there yet with quantum. And people also often struggle with understanding, which kind of hardware they want to use, because, we haven't even agreed what's the right qubit that we want to use for a solution. And if you really get deep into it, right, even for superconducting qubits, you have fluxonium qubits, you have transmon qubits, and different ways of doing it. And the same for trapped ions. So people are often confused on, where do I start? How do I go? Luckily, there are multiple initiatives, at least in the UK. You have the National Quantum Computing Center, which provides resources, and many academic institutes and hubs are providing resources for such purpose. But it's getting over that hump. That has been a big barrier. But purely from an industrial perspective, I would say identifying the problem in itself where these tools could be used. This is not a skill many seem to have. which is also understandable. That's where we come in. We have been working with multiple partners on these solutions. And because we are not a quantum native company, we don't need to be selling a solution for the sake of it. We often think that, what is the right solution? What's the best way to get there? And which is quite helpful in assessing even quantum advantage and the claims that surround it.
Thank you. Yeah. So, Richard Padbury, from the perspective of Falgun just talked about how important it was to understand the right problem. When you're talking to clients, externals, are they bringing you the problem, or are you generating it internally, or is it a combination?
It's a combination. Yeah, it's again, some partners might not know where to start, and so we help guide that conversation and pinpoint where the right places might be to explore quantum. Other organizations may have done that upfront work and have identified some very key strategic areas where they believe quantum may provide an advantage, and then we're there to help obviously implement that solution using the best available tools and hardware. So I think it's there's a lot of unknown unknowns. It's still this is still an active area of research. What does a good quantum problem look like? We're still actively trying to understand that question ourselves. But I do think for an enterprise, for an organization, it helps to look at, every enterprise will have a business strategy. Maybe that strategy is over a 5-year period. So you can use that to look at where the organization is trying to get to, what classical methods are used today, where are the bottlenecks, and therefore where might quantum play a role. So it's kind of a high level approach. And again, some organizations may have already been through that process. Other organizations are still dipping their toes in and sort of trying to get to that point.
Okay, I'm going to come back to you because I do want to ask you about that space travel comment that you made. But I'm going to go over to Richard Gavan. From an economic value perspective, obviously companies who are going to be investing in your tools are looking for some sort of return or an economic value. Is it really is time the key factor? Is budget the key factor? Is there something that people are talking to you about that gets them interested?
Yeah, I would just say that people aren't getting repeatable commercial value from quantum computers today.
Right.
I think you can argue there's a niche scientific advantage already, but there isn't repeatable commercial value. So what would you assign value? Well, you would say that people are in some sort of strategic race to yield benefit from quantum computing before their competitors, at least in enterprise. I mean, for the altruistic academics in the room, it's just about sharing knowledge. For enterprise, it's about competing. And there's a timeline to get there, and that's an empirical process. It's an empirical process, meaning, you develop new ideas and you test them and you find which succeed, and then you try and scale those to production scale. That takes a while, and whoever does it more quickly will yield the benefits of commercial advantage before their competitors, and it won't be very. I think you'll know there's advantage when you see the consumption of quantum computing go up and the industry get relatively quiet about new applications. Right now, we're all very loud because there's inherent value in doing press. But when there is value, not just in the press, but in the application itself, you can expect people to get more cagey, not academia, of course, and that's why it's a wonderful thing. But yeah, the value is definitely in winning the strategic race to advantage. If you're a bank, for example, it depends on the domain. If you're in a pharmaceutical domain, maybe you make a new discovery, but maybe it needs to follow then like a long clinical trial time span for it to yield direct value. If you're in a bank and somehow you're calculating risk or optimizing a portfolio better, your bottom line is immediately hit. And so the value is immediate once advantage is there. So it depends on the domain, but yes, it's all about speeding up time.
And this is what we wanted to talk about in this live event session, that it wasn't just simply all hype or, great expectations in the near term. It's so important to get started. Sasha, when Richard talked about working together, how important is collaboration in the work that you're doing?
It's hugely important. I I would say that quantum computing is still at the stage where we need to understand what to solve with which tools, both at the hardware and software level. And until you start talking and discovering what are the real challenges that hardware companies face or the end users actually encounter, you are not building any relevant tools, any useful algorithms. So collaboration is important, and in my experience, what really helps is to have events that gather different perspectives where people can discuss. And of course, um, webinars like this help when you bring people from academia perspective, from industry, and ask challenging questions.
Fantastic.
Mhm.
Falcon, you and Richard are a perfect example of working together. The link you kindly put on our chat talks about a document that you worked on together.
Yeah, yeah, absolutely. And also we work quite closely with Haiqu and other organizations as well. So when I got the invite and I looked at the panel, oh yeah, these are all the people that I know and I worked with in the past. So yeah, and I genuinely think collaboration is really important at this stage as well. So Sasha, I totally agree because we are we are in still very early stages, and genuinely there's space for everyone to operate here. I think this is not the time where everyone's hiding their own research and trying to see what's the best IP, because we still have to understand. I mean, Richard Padbury, you mentioned this earlier. This is a place where there's just not a lot of known unknowns, but it's also the unknown unknowns that we need to figure out. And unless you're collaborating and asking the hard questions and not just going for the low hanging fruit on what is easy, or can I get an easy press release, or can I publish something quickly? But it's really thinking about what adds value. Because at the end of the day, so right now we have a lot of funding, we can look at these problems, but what we really want a few years down the road is large scale enterprise deployment. We want this to be self-sustaining without having government funding opportunities, and we're not just looking at toy problems. So this is where collaboration and asking the hard questions, even if the answers are not really what you expect, is going to be a key part of us moving forward.
That's fantastic. So, Richard Padbury, there's a lot of things that are driving the momentum in the quantum space, whether it's companies going public or things like the US executive orders or France's software mandate. How are you seeing that sort of playing out in the sort of the greater quantum ecosystem, and is it impacting quantum R&D?
Yeah, I think my short answer would be that all of these are essential signals and developments that are happening in the broader ecosystem that keeps quantum at the forefront, and it keeps the investment and the developments continuing. And I think that's really important right now, because I do believe, in the next couple of years, certainly we're on the cusp of some really interesting developments in the quantum space, especially if you look at how the hardware roadmaps are progressing. So I think it's great that governments are supporting. I do agree with Falcon that obviously as an ecosystem, we all need to show value at some point, whether you're an end user, a service provider, developing software, providing hardware. As part of this broader ecosystem, it needs to be sustainable, and so that's obviously where we're trying to get to.
Fantastic. So, Richard Gavan, are standards yet playing a role in the software space, or is it a consideration? How is it playing in?
Yeah, I mean, I would say a lot of people like to use Qiskit, but there's other things you can use. It's still amorphous because we're not yet in a production level setting.
Yeah.
So standards become the most important when you're in a production level setting. And so you can argue, okay, there's no fully mature standard because we're not there yet. I think one thing that we think about a lot is if you assume that agents are significant contributors of quantum code now and in the future,
Mhm.
then the question of standards becomes what standard does an agent default to? and generally speaking, they default to the sort of the best documented open standards. Qiskit is a great example of that, but there's others. Bracket is also great. Haiku is going to release some open source libraries around orchestration and application development that we are engineering to be easy to understand for agents and for people. So I think standards are an ongoing battle. It's not just about getting to production, it's getting to production in a hybridized manner. So you need standards that are interoperable with classical computing standards. So a lot of people are working on this. I think the dust hasn't settled, but I think that agents will be a forcing function to settle the dust and choose the dominant standards.
Okay, one of the questions I always get is about whether you're going to use a fully autonomous system or, like you've described, where there's humans in the loop for creativity purposes and so on. Do you see that fully autonomous function happening anytime soon? Or is it truly, the best systems are hybrid?
The best systems definitely have people involved, but there are things that could be done autonomously. Let's say like you and your agent friends have developed a new application, you tested it, it works, it shows advantage, great. The hardware is constantly changing. There's also new types of hardware coming online all the time. How do you make sure this application you've built is running at the greatest possible scale if the hardware is changing, or running on the most intelligent modality if there's new ones coming online? That is a process that you could automate, and you could have, let's say, a living application where you've built it, but now the agent is redeveloping it for any change or introduction of new hardware. So there are things like that that can run autonomously. Also, just continuously scanning the literature for new techniques that might improve your application and then test those within what you've already built. There's always going to be a person involved, but I think as you move to production, you're going to want to push a lot of processes autonomously so you can focus on the creative work.
Okay. I'm going to go over to you, Richard Padbury, because, Richard Gavan mentioned, modalities. And, are modalities important to end user communities? Is it now becoming more agnostic with the intermediary platforms? I guess those are my questions.
Good questions, tough questions.
Yeah.
Obviously the hardware space is growing.
Yeah.
Although I would say there are certain modalities that have been around for longer and are potentially more well established. And I do think it's important to build intuition across these platforms. And so we factor that into the work that we do. For certain use cases or POCs, will a certain hardware modality provide a better solution compared to others? And obviously a big research question right now is, will we live in a world where we're actually orchestrating jobs across, 2 or 3 quantum modalities, along with obviously the classical piece, and orchestrating solutions across those different modalities? That is an open question right now in the field.
It really is. And, it's there's so much movement in each one of the modalities. And some platforms are making it somewhat agnostic by allowing you to use several at the same time. But Falgun, can you give us an example of a use case that you're working on today without giving us anything confidential? Just something generically you're working on today.
Yeah. So something that we have been investigating. So this is not purely a quantum computing topic, but for me, quantum computing is a tool. But we have been investigating this topic of corrosion. And as a part of that, we want to be studying specific reactions. So, I can speak about this part because this is public information. So we have been working with Airbus. We've published papers on this. They're interested in understanding a very specific aluminum alloy. And it's this 2000 series, which has copper added on to make the alloy, because it gives it the structural strength. But it also, you want to be using aluminum because it's quite lightweight. But because of this presence of copper, there is this oxidation reaction that happens, which leads to corrosion because of this electron transfer. What we have been trying to study over the past couple of years is this very specific reaction, which is, without getting into the details, it's really important for us to study. That way we can model how this corrosion actually propagates. And this reaction is very difficult to study experimentally. We need to have conventional theoretical ways or computational ways of understanding it. And it's a massive challenge using today's methods, existing methods. So what we have been doing is developing the overall strategy where we are able to solve parts of it using a higher level of theory and parts of it using a lower level of theory, and how do we do this in a most effective way. And as quantum computers do develop, where would they actually fit into this pipeline? So this is an ongoing investigation, and we are also, as a part of this, even involved in resource estimation. So our part of Capgemini, because as I mentioned, it's quite big. Cambridge consultants who are based in Cambridge, UK, they work quite a bit on resource estimation. So they have been trying to find out where is this crossover point for this specific reaction. But along the same time, today we're working on what would a solution look like, what's the level of approximation that we need, and then as the technology matures purely from a quantum perspective, how do we actually put it as a part of a wider workflow? Because at the end of the day, tools, I mean, they're important, but it's only such a small part of the equation. They don't really lead to the final decision making, which is what we try to focus on.
Okay, fantastic. That's a really tangible example. So now I'm going to, just at the end of our session here, ask each person to give me their final thoughts. I'm going to start with you, Alexander. You were kind enough to put up a link to the algorithm that you developed with Siemens. Thank you very much. But for our audience, we brought the topic, Are Agents the Secret of Quantum R&D Success? What are your final thoughts on that?
I believe that we still don't know. Is it a secret? But it may as well be the answer, because if what we see nowadays is scaled up, we can put agents overnight, we can give them a possibility to explore, and if we understand the little tricks that are being picked up by the agents and merge them together, I believe we can have solutions that are very difficult to find otherwise. Of course, the other option is that agents become our tools to push the boring research, but the ingenious part will still be developed by humans. That's, of course, preferred way, but I think the question is open, and we will discover it in the next few years.
I personally like the picture that you've painted there. That's fantastic. Richard Padbury, just what are your final thoughts for today's session?
So I have like 4, if that's okay.
too.
I mean, I think the first one is that agents are useful tools, and I think anything we can do to bring the time to a solution down is a beneficial thing. And I think anyone that's been in the tech space and has developed AI models will know there's lots of things you have to tune and set up before you get to that final model. And it's similar with quantum. So anything we can do to make that process faster, simpler, is, I think, beneficial. And then I think there's just 3 things I would highlight. First, readiness is so important. And we have a window now where organizations can get ready. And this might be an overused analogy, but if you think about ChatGPT that came out of nowhere, but if you connect the dots backwards, those developments were happening in the background for decades. There was the first paper on the transformer model in 2017, and then 5 years later, this tool is made available to the public. But it came out of nowhere, and it's really hard to develop on that inflection point. So now is a really good time to actually get ready. And then I think important thing for everyone to understand about quantum advantage is that it's a moving goalpost. So quantum hardware and software is going to continue to develop. Classical methods will as well. But there's a really interesting tension between these 2 capabilities, which again is beneficial overall. So I think those are my main things. 3 or 4 and I'll stop talking now.
Oh, that's fantastic. And that's exactly why we brought you here today. Really appreciate those insights. I'm going to leave our host, Richard, to the end. Falcon, how about yourself? What are your final thoughts?
Yeah. I mean, I was going to say it's a good and bad thing that Richard Padbury is on the call, because we share a lot of similar viewpoints and we have a few papers and joint works together. But also, he's covered a lot of the things that I wanted to say. But
sorry, Falcon.
No worries. But because you asked a yes or no question at the beginning, Brian, are agents the secret to quantum R&D success? I'll start by answering that. Maybe a little controversial, but I'd start by saying no.
Okay.
I'd say that not because I don't think agents are useful. I absolutely think agents can accelerate discovery, but they cannot determine the significance. The competitive advantage for me, it comes from knowing what are the right questions to ask, what questions matter, how do we act on those answers that we receive to make the decisions. Because we always, when a problem comes to me, I think about, how am I going to think about this problem to begin with? It doesn't come from a place where I'm thinking, oh, what's the tool that I'm going to use? What's the agent that I'm going to use? No, it's the problem and how am I thinking about the decisions? Because at the end of the day, if you want to deploy something commercially, that's a business decision that has to be made. Underneath that, you have to make a ton of engineering decisions, not all of them related to like simulations at all. You have multiple layers, you go one layer after the other, and then what's the outcome that I expect? So that's the hierarchy that I follow. So it's never about the technology. It's not about the platform. It's not about the quantum hardware and the tools that come in. Again, it's not to say our agent's a secret. That's the reason I say not really, because the bottleneck is not actually not the hardware. It's not the algorithms and agents. Again, not to say they're not important, but it's selecting the right problem and thinking about how do we tie it in with the decision-making process. For me, that is the missing link, and that is the most significant element. And that's why you need solid scientific judgment, which comes from a lot of training and experience and exposure. But that's where collaboration also plays a really big role. So this is what I want people to like walk away with from my perspective.
Well, I don't know if you noticed, but a lot of people agree with you. There was a lot of clapping hand emojis coming up. So, well done. I will ask Richard Gavan, one of our hosts, to provide his final thoughts for today's session.
Yeah, I have to say that I agree with all the thoughts and Falcons as well. I mean, it's ultimately the creativity of the team behind the wheel that will determine whether people find advantage sooner than others.
Yeah.
The agents simply speed up the process. And so I can just tell you anecdotally, we use all of our own tools internally. We are now doing work that would take months in weeks, and some work that would take weeks in a couple days. So we find a lot of value out of it now. It's not yet at production scale, but I think the truth and I see questions in the chat. Will it be like AI? Will it replace people? Right now, there are too few people in quantum computing of, let's say, the research engineer archetype who have a good command of the theory and a good command of the practical quantum software engineering skill set. And it's a real issue. And it's hard to fill a skill gap problem without just more people. And if you look at the rate at which people are graduating with the requisite skills, it's not enough to track what we expect to be the growth in quantum computing. So we view agents as a requisite component to fulfill the skill gap and speed teams up. Is it the secret? I don't think it's a secret. I think they're increasingly prominent across all domains now. But I really have to agree with Falcon. You need experts that understand their respective domain and can weight the importance of working on a certain problem. I think it was Cicero, that said, if a ship knows not to which port it sails, no wind is favorable. Yeah. And I think it's applicable here. So the agents will speed you up, but you need to pick the direction.
Well, that sounds like a great way to end off our session today. I want to make sure that people take advantage of the resources that are available to you. Please click or check the links that were in the chat. Check out the Haiqu website, and those for Capgemini and KPMG and what's going on at the Sheffield Quantum Center, as well as our host, the Quantum Insider. We are thrilled with the opportunity to come and talk to you about a very sort of provocative statement around our agents, the secret to quantum R&D success. And you can see there's lots of different perspectives, and we're thrilled that you came and enjoyed us today. Thanks very much. We'll end off our session.
Thanks, everybody.
Thank you.
Thanks, everyone.